Okay, we are going to solve the final test. Test 4, first question. It says that you have a relation like this one, a plus b plus c equals 0. So it gives you a, it gives you b, and it says who is the vector c that produces the sum equals 0. Is this one going to the right? Is this one going to the left? Is this one going up or is this one going downwards? And the correct answer is this one. Should be this one because a plus b is the vector, a plus b is the vector a plus b is the vector c, is the vector. This one is a plus b. This one is a plus b. Now I have to add a vector to produce 0. So the vector c that I need to add should be this one, the one that is going downwards. So in this way, a plus b, this one, plus this one, will be 0. So this is the only possible expression. Okay, here it say they show you x and t, 5 regions, and it say for each region mark whether the velocity is positive, negative, 0, whether the acceleration is positive, negative, or 0. Okay, you see that this is position versus time. The position in the region 1 is negative. The velocity is positive. And the change in the velocity, that is the acceleration, the velocity is positive because the slope is positive, is always positive here. The slope is 0 here, so this is the velocity. And in this region, the slope is negative, so the velocity is negative. The velocity is the measure of the slope, delta x divided by delta t. Okay. Now, respect to the acceleration in every region, we have the slope, the delta x divided by delta t, that is the velocity. The acceleration may measure the change in the velocity per unit of time. So it's the change in the slope. So the acceleration will be, here let's say that the velocity is positive, and let's say 5 meters per second. Here let's say that the velocity is also positive because the slope is positive, and it's bigger because it has a bigger slope, so the velocity is 10 meters per second. So there is a change in the velocity, 5 and 10. From 5 and 10, the change is final 10 minus 5. The change is positive in the region 1. Let's go to do, so the acceleration is positive because the change in the velocity is positive. So in region 1, the acceleration is positive. Region 1, the acceleration is positive, and the velocity is also positive. Let's go to analyze the same thing in the region 5. In the region 5, the velocity is negative. Let's say minus 10. Now it's a smaller velocity. Let's say minus 5. Final minus initial is the change in the velocity. So this is positive or negative. You see that the change in the velocity is positive here, because it will be minus 5 plus 10, it will be plus 5. So the change in the velocity is positive in the region 5. So what is the correct answer here? The correct answer is the D. In the region 1, the velocity is positive and the acceleration is positive, while in the region 5, the velocity is negative and the acceleration is positive. So It is the question 2. Let's go to answer the question 3. It's a ball throw horizontal from the top of the building lands distance d from the top is launched horizontally. So he arrived at the distance d, yes, from the foot of the building. This is the building. After having in the air from time t. So the time to arrive to the floor is time t. Now, if I have a building that is double H0, for a building with H0, with this H, the equation that will happen for the y in the y direction for the y will be a motion with a constant acceleration. The acceleration will be minus g, so the equation will be y equal h0 minus 1/2 gt0 squared. T0 is t the time. When y is 0, t is t0. Okay? When y is 0, t is t0. H is, so the equation would say that h0 equal g divided by 2 t0 squared, or t0 equal square root of 2 times h0 divided by g. If you do the same thing with a h, with a building double h0, when y equals 0, when y, you place the equation, when y equals 0, 0 equal 2h0 minus g divided by 2 by t squared. We don't know which time is this one, t. Okay, so 2h0 is g divided by 2t squared, so t squared is 4 times h0 divided by g. So t squared is 2 by 2, that is 4, is the same equation. But this is t0 squared. So t squared is the double that t0 squared. So the time t is a square root of 2 t0. This is the answer. Okay, go to the next question. The next question says, there are two forces. The correct equation for the acceleration of the boy in the direction parallel to the plane, well, I have mg here, that is the mass of the body by the acceleration. I have the component of the force of the weight in this direction, that is mg sine of alpha, and I have a force going up that is F1, but it's not exactly F1. This force going up is, this one is F1 cosine of beta. And this one, the one that is going parallel to the plane, is F1 sine of beta. Okay, so I have force going downwards, mg sine alpha, so I choose the positive direction. I don't know to where it will move the object, because it could accelerate it upwards, or it could upward in the parallel plane, or it can accelerate downwards. But if we choose the positive direction going downwards, so this is the positive direction, so the equation will be mg sine of alpha going downwards, minus F1, the magnitude of F1 by sine of beta, minus F1 by sine of beta, and this is m by a. So the acceleration, I have to correct. The acceleration is F1 divided by m. Here is m. I have to correct. I have to correct this. So the acceleration is if I divide by m, this m will disappear, okay, and will appear the m here. So the equation is mg sine of alpha going downwards minus f1 sine of beta going upward equal m by a. So the a I divide by m is g sine of alpha minus f1 divided by m sine of beta. So this is the value of the acceleration. So the acceleration is this one. So which one is the one that we look? Is this one. This one is the C. I'm going to correct on the original test. Then this problem say like this. You first of all you make a force to store energy on the spring. So you make a force, external force, you store energy on the spring, an amount of energy, 1/2 kx squared. You release the one that the spring is compressed 0.20 meters. You release the mass in a friction surface. So what it's asking is when released, the block moves on a horizontal table 1 meter. So it moves 1 meter until it's stopped, until it's go to the rest. The spring constant is 200 newtons per meter. What is the coefficient of friction? If K is 200 newtons, what is mu, the mu here? The answer is the second one. And why is the second one? We are going to understand why is the second one. So the theorem of work and kinetic energy will say that the net work, the total work done by all the forces equal the change in the kinetic energy. So here there are two forces. Here there is the force of the spring and there is the force of the friction. The force of the spring will produce a positive work going from here to here and will act only during the distance delta x, that I will call it x in the equation, like this, x. And the work done by the spring, by the force that the force of the spring will be kx. Indeed, the force is minus kx, but because it's going to the right, because it was compressed, it was in the left side of the compression, so the force is going to the right. The force and the displacement is going in the same direction, so the work is positive. So the work will be the area that is below the curve, and the area below the curve will be the area of the triangle, and the area of the triangle will be 1/2 the base x, or the compression delta x, by the height kx. So the work will be 1/2 kx squared. So I return to our original equation. The net work is the work of the spring. The work of the spring is 1/2 k by the compression square, plus the work of the friction. The work of the friction, meanwhile, is going to the right. The friction force is going to the left. So the work of the friction is negative. And the work of the friction is mu, this the friction force by the displacement. But the friction force is mu by the normal. Mu by the normal, mu by mg, by the displacement s. The total displacement s is 1 meter. From here to here is 1 meter. So this is equal to the change in kinetic energy, final minus initial. Final kinetic energy, 0. Initial kinetic energy, 0. 0 minus 0, 0. So this produces an equation that says that 1/2 kx squared equal minus mu mg by s. So x squared, so mu mgs equal 1/2 kx squared, so the mu will be this value, 1/2 kx squared divided by mgs. So if you plug in numbers, it will be 1/2, 200. The compression square is 0.2, or 2 divided by 10 squared, divided by mg. The m is 2 kilograms. The g is, let's say, 10. and the S is 1 meter. Now the mu will be 1/2 200 4 divided by 100 divide by 20. So it will be 1/2, 4 divided by 100, 4 divided by 100, 200, so it's 4 by 2 is 8, divided by 20. So it will be 1/2, 4 divided by 10, or 1/2, 5, 2 divided by 5, or 2 divided by 5, or 2 divided by 10, or 0.2. So the correct answer is 0.2. Okay, this problem say you have 2 blocks, one 3 kilograms, the other 6 kilograms. The blocks are in an initial state of compression. They are released. There is no frictions. The spring have a negligible mass, is not fastened, so they are compressed, and they will, after the release of the spring, the block B will be moving to the right, and the block A will be moving to the left. And all the energy that is stored here will be transformed in kinetic energy. So the problem say that you observe that block B is at velocity 1 meter per second. And it say what is the final speed of the block A, and what is the energy that was stored in the compressed spring. So to find first the final speed of the block A, we apply a principle of conservation of momentum. So the data is MA 3 kilogram, MB 6 kilogram, and the VV final is plus 1 meter per second going to the right. So if we apply the conservation of momentum, we say that the total momentum initially equal to the total momentum finally. This is a vector. The total momentum initially is 0 because both of them, the A and the V, is at rest. So the final momentum is MAVA plus MVVV, but from here we know that minus MAVA equal MBVV, so VA will be minus MV divided by MA by VV. Plugging the numbers, we found that VA is minus 6 MV6, MA is 3 by VV, so minus 2 meters per second. So the final state is that VA is moving to the left with 2 meters per second. So it's minus 2 meters per second, so the magnitude of the velocity of the VA is 2 meters per second, and this VV is moving, it say the problem, 1 meter per second. So we respond to the question. So VA should be, so the correct answer should be the V because it appeared this velocity. Now let's go to find the compression. To find the compression, we say like this. The mechanical energy at the beginning, A, equal the mechanical energy at the final state, when they are running, when each object is running. So the mechanical energy at the state A, or at the initial state, is kinetic energy of A, 0, kinetic energy of V, 0, and the energy that is stored, 1/2 kx squared. On the final mechanical energy, the compression is 0, so the mechanical energy, the stored energy is 0. There is no energy stored on the spring, and everything is kinetic energy. So you have converted potential energy of the spring into kinetic energy of the two masses. So this is the potential energy is 1/2 the mass by the velocity square plus 1/2 the mass 6 by the velocity square. If you make numbers, this will be 9 joules, so the correct answer will be the B. Okay, let's go to solve this problem. It's say a light string is wrapped around the outer rim of a solid radius 1 meter and can rotate without friction about an axle through the center. So the moment of inertia this is 1/2 mr squared. A 3 kilogram stone is tied to the free end. This is the 3 kilograms and release. You determine that the stone reached the speed 3 meters per second after falling 4.5 meters. What is the mass of the cylinder? And the answer is this one, and let's go to find this answer. The object is falling down, and it's falling down 4.5 meters and it reached the velocity 3 meters per second. Okay, so the delta y, the delta y is related with the v square, like v square is a motion with constant acceleration, v square equal v0 square plus 2 times a by the displacement. V0 square is 0, so v square is 2 times a by the displacement. So the acceleration is going downwards, and it's v square divided by 2 times delta y. V is 3 meters per second, 3 squared is 9, divided by 2 times 4. So the acceleration is 1 meter per second square. So we apply it slow to the mass of 3 kilograms. So the tension will go up, the weight will go downwards. The weight is bigger than the tension going upwards. The weight is bigger, so the mass by the acceleration of 3g minus d is equal ma. So the tension would be 3g minus ma. So this is the tension. And the tension produces a torque here. This is also the tension. This is the tension. The tension produces a torque and produce angular acceleration. So the torque will be T by R. Is the force perpendicular to R. Force perpendicular T by R equal I by alpha. T is 3g minus ma by R equal I by alpha, but alpha is related by A equal alpha by R. The tangential acceleration is the angular acceleration by the radius. So the rope is moving with acceleration with tangential acceleration, and the disc is moving with the angular acceleration of the disc is A divided by R. So we plug in this A divided by R, we have this equation. So this R multiplied by this R is R squared by 3g minus m by a is 1 meter per second squared. So it will be I, 1/2 the mass by the radius square, that is the moment of inertia, multiply by 1, I by a. The R is here, R squared. So the radius is 1 meter, so 1 squared is 1. 3 by g is 30. 30 minus m is 3 kilograms. 30 is 27. 1/2 m by 1 squared. So the mass is 2 times 27, which is 54 kilograms. So the correct answer is 54 kilograms. Let's go to see the next. Okay, to solve this problem, we are going to use the conservation of angular momentum respect to this point, the center of the disc. So the bullet will arrive, and the angular momentum will be conserved, is always conserved in an interaction of two bodies. So we measure first the initial momentum. The initial momentum, that this is not rotating, have no angular momentum. The only object that have angular momentum is the bullets. So the angular momentum of the bullet will be the mass by the velocity by the radius perpendicular to the velocity. So the velocity is going in this direction, v. So the radius perpendicular to the velocity is r divided by 2. So this produces an angular momentum of 3 units, 3 kilograms meter squared by second. So these 3 units, they are conserved. So what is the angular momentum after the collision? After the collision, you have the bullets included inside the disk, and they are rotating together. And they are rotating with a common angular velocity. So the angular momentum final respect to the same point, to this point, is the mass of the bullet by the velocity of the bullet by the perpendicular distance with the velocity r divided by 2. This is the new angular momentum plus the final angular momentum of the bullet plus I omega, that is the angular momentum of the disk. But because they are moving together, the velocity of the bullet will be omega by r, but r is r divided by 2, so the velocity of the bullet will be omega by r divided by 2. Multiplied by r divided by 2 will read as omega r squared divided by 4 plus I omega. So I have L final equal L initial. L initial is 3. And L final is a mass of the bullet by omega, here, this omega, r squared divided by 4 plus I, common factor is omega. So omega final, this is the omega final. Omega final is 3 divided by all this, mass of the bullet r squared divided by 4 plus I. So you plug in numbers and you will find approximately 1.5 radians per second. And this problem contains a lot of tools that we have to use to solve the problem. In the first step, if you read the announcement of the problem, on the first step, this mass, MA, we are going to apply conservation of energy to find the velocity of the mass MA just before the collision. Okay, once that we find the velocity before the collision, we are going to find, because the problem says that both of them will have a collision and will stick together, we are going to apply conservation of linear momentum in this direction to find the common velocity that the two masses will have immediately after the collision. So in the first step, we apply conservation of mechanical energy to MA. It's important to recognize that the tension, this tension, doesn't make any work because the displacement is perpendicular to the force, to the tension. So I can apply conservation of mechanical energy. On the second step, we apply conservation of linear momentum to the collision of MA with MB. And on the third step, we apply conservation of mechanical energy energy to the object of mass ma plus mv, because they go together. Okay, let's go to do it. The first step is done here, conservation of mechanical energy to ma. So what I have is potential energy. The potential energy is converted into kinetic energy before the collision. So I find the velocity before the collision. This is the velocity before the collision. Second step, conservation of linear momentum. I have an object coming with certain velocity, this velocity, and it's going to collide with mv. And after the collision, both of them will move together with certain velocity. What is this velocity? Is here. The initial momentum ma by va equal the final momentum ma plus mv by v. So this velocity v, the final velocity after the collision, will be v equal ma by va square root of 2gh divided by ma plus mv. If you plug in numbers, you will find this number. And the second equation that you need to use to find the elevation of the mass ma plus mv is to apply conservation of kinetic energy, the third one. I'm here now. So if you apply conservation of kinetic energy, we'll say 1/2 the mass by the velocity square. The mass, ma plus mv, by the velocity square, equal ma plus mv, equal with the h, the maximum h. This h is different than this initial h, the h maximum. So this, if you plug in numbers now, you have everything, and it will be this. Here there is 1/2, right? There is 1/2. 1/2. So the h will be 1/2, 25, 5 squared, square root of 2 is 2, 13 squared is here, and g. If you do it, I think I forgot the 2, so it will be 1.5 centimeters. 1.5 centimeters. So let me erase here. Sorry. Very sorry. This is 1.5 centimeters. 1.5 centimeters. Let me erase also here. Okay. So this is the elevation. So now I have this problem. This is 1. This is 1. This is 1. This is the radius, 1 meter, 1 meter. I know that this h is 1.5 meters. And I have to find this angle theta. How I will do? Well, this is 1.5 meters, 1.5 centimeters. So let's go to put it in meters. Is 1.5 by 10 minus 2 meters. So this is 1.5 by 10 minus 2 meters. Okay. How I will find this angle? Okay. So this part is 1 minus 1. This is the triangle that I see. You see? This is 1 minus 1.5 by 10 minus 2. And this is 1. So the result will be I have this is 1, this is 1 minus 1.5 is 0.985. So what is the, so this is, if this is everything is 1 and this elevation is 1.5, it's clear that I made a triangle this side is almost 1, it's 0.985, and this side is the 1. Because you see the picture, this is 1, everything is 1, is the radius of rotation of the pendulum, no? So the theta, it will be a cosine of theta, 1. Cosine of theta will be 0.985. So theta is almost 0 degree, because cosine of 0 is 1. And this is very near to 1. But theta, if you go to your calculator, it will say how many radians, or how much it say, I don't know. You will, let me see what it say. The problem say to find the maximum angular displacement. So once that you have theta, cosine of theta is equal to arc cosine of 0.985. And this will give you in radians, will give you for sure maybe 0.1 radians, I don't remember. And the other thing is that they asking is the period of the frequency of the oscillation. And the frequency, if you go to the pendulum, let's go to see the pendulum. This is the pendulum. This is T going upward. This is mg. So the motion is here. So this is mg. This is theta. And this is mg sine of theta. And this is the force that exists in the s direction. This is the s direction, the direction of the motion. This is the x direction. So the force is mg sine of theta, and fg sine of theta is the acceleration in the s direction. In the s direction. The s direction is the direction through the curve, through the circle, to the circle. So it's mass by acceleration. So the acceleration will cancel. And in the case that I have theta very small, like this one, if theta is small, sine of theta is the same that theta. Sine of 0.1 radians is 0.1 radians. So the equation will say G by theta equal AS. And now I have to relate the theta. You remember that this is theta, this is the arc. Let's go to call the arc S. S equal the radius L by theta. So theta is S divided by L. So I will put it here. G by theta by S divided by L. Now there is a sign here, that is a minus sign here, because the acceleration is going in the direction negative to the theta. Theta is positive going in this direction. And the acceleration is going in this direction, in the negative direction. So the real equation is this one, minus G by Sorry that the sound was off. Let me fix it here real quickly. So what I have said is that the force that is causing the motion through the circle is here, is mg sine of theta, this force, this one, this force. This force is the force in the s direction. And the force is in the s direction is the mass by the acceleration in the s direction. And the force is mg sine of theta. This is theta, this is mg, and this is mg sine of theta. So if theta is small, sine of theta is equivalent to theta. For theta very, very small. For theta less than 1. For theta less than 1, sine of theta is equivalent to theta. In radians, of course, we are talking in radians. If you test it in your calculator and you put sine of 0.1, sine of 0.1 will be 0.1. So the equation that we are going to place, this minus comes of the facts that when theta is positive, the acceleration is negative. The acceleration is going in this direction, in the opposite direction of the positive theta. So in the other side, if you see the other side, you will see that the acceleration is going, mg sine of theta is going, g sine of theta is going in this direction, and the angle is going in the opposite direction. So there is a minus sign here. Okay, so this is the equation. So, sorry, this is the equation, and if you write theta, you remember an important equation that I have always said is that the arc equals the radius L by the angle. So the angle theta can be expressed like the arc divided by the length. So I will plug in theta here, S divided by L. And I would say, okay, when I have an equation like this is the equation of harmonic motion. So what is the omega square? What is multiplied to x? The coefficient that is multiplying the x is the omega square. So in this equation I have as equal minus omega square, or omega square by s. So as, the omega is what is being multiplied. Omega square what is being multiplied by the s, by the parameter s. Equally here, the ax is what is multiplied by the x. So the omega square, I have identified the omega square like g divided by L. So omega square is g divided by L. So omega is square root of g divided by L, but omega is 2 pi by f. And this is the square root of g divided by L. So the frequency f is equal to 1 divided by 2 pi square root of g divided by L. Or if you calculate 1 divided by 6.28, it is 2 pi. G10 divided by 1 is 10. Square root of 10 is like 3 point something. 3 divided by 6 is like 0.5. 0.5 seconds minus 1. Let's go to the next problem. So the next problem, you know what it say. It was on the test. And it say find the total force, the net force on this one. So we need to sum this force with this force, the mass mc, and both of them are attractive force. The mass mc is at the distance x0. This mass is at the distance y0. So how I will do? The problem is asking me for the magnitude of f, for fx, fy, and the angle alpha, or the angle with the x-axis, this angle. I think it was asking on the original problem. So It gives you also numbers. I don't know if I have changed here the numbers. It gives you x0 30, y0 30. So x0 30, y0 30 will mean that this angle is 45 because tangent of alpha is y0 divided by x0. So the angle alpha will be 45 degrees. Okay. And the force acting on MC, on C, due to A, it will be G by one mass, by the other mass, divided by the distance square. But the distance square is this square, 30 square plus 30 square. So it will be G by 1, divided by C, 30 square plus 30 square. 900 plus 900, 1,800. So it will be G divided by 1,800. This is the amount of force in this direction. So now I will see in the problem that if I take this, the force in the y direction will cancel with the force in the y direction due to the mass, to the force of attraction of the other mass. So it would remain one force in the x direction due to this, and the same amount of force due to this force in the x direction. So the force in the x direction will be 2 times F cosine of 45. 2 times F, 2 times the magnitude of F will be G divided by 1,800 by cosine of 45. By cosine of 45, that is square root of 2 divided by 2. By square root of 2 divided by 2. So this 2 will cancel with this 2. The result will be, let me erase here, will be G divided by 1,800. Okay, G divided by 1,800 square root of 2. And this is the net force, the sum of all the forces in the x direction. The sum of all the forces in the y direction will be this amount, that will be 0 as we see in the problem. So the correct solution is, what is the total force in the x direction? This one, or this one, G divided by 1,800 square root of 2. Also can be written like G, if I multiply by square root of 2, 1,800 by square root of 2, it will be G by 2 divided by 1,800 square root of 2. This is the first piece of information for the magnitude of F in the x direction. So this is the force in the x direction. The sum of all the forces in the y direction is 0. What it say more? And the angle alpha is 180 minus 45. The angle alpha, no, the angle theta that makes with the x-axis is 180 minus 45, or 135. Okay, 135, right? The angle, sorry, the angle that makes the net force is 180. 180 is the angle that makes with the net force, because the net force will be here, will be here. Okay, this is the net force. Okay, let's go to draw the next force. It will be this one. The sum of these two forces will be this one. Okay, so the angle will be 180. Okay, the angle of the net force. It say, let me read it, it say the y component of the net force, the x component of the net force. So I'm going to correct it in the announcement of the problem. Okay, that's all.